So today we are going to discuss exception handling in Java. It's not a big session, it's a very small session. Let's do the session, and at the end we will try to do some past step questions as well. Okay, right. So let's move on to the exception handling in Java. Right. So we are going to cover two topics here. That is the type of errors that encountered when it comes to software development or programming, and after that we are going to discuss how the Java exception handling framework or the exception handling mechanism works. Okay, right. So let's first move on to the what are the different type of errors that involve or we encounter when it comes to developing software. Right. So there are different categorizations. So we are going to look at few categorizations. The first categorization is the syntax errors versus semantic errors. So we can subdivide errors into syntax errors and semantic errors. So when it comes to syntax errors, it is something like grammar in natural language, right? So for example, if you say I are going to school, that is definitely something wrong with that grammar. So similarly, when you are writing your program in computer programming, you can't break. There are some rules, we call them syntax rules, which you can't break. If you break those rules, the compiler is going to stop compiling, or if it is interpreted language, it is going to stop running the interpreter on the program. Okay, so those are called syntax errors. Right? So there are some popular syntax errors you encounter, especially if you are a little bit careless. That is missing semicolon, missing keywords, invalid use of control structures, right? Then invalid assignment of data to a variable, especially if it is a strongly typed language. For example, if you can't have a variable called int x, and if you try to assign something like 10.5 or something like hello, you are going to get a syntax error, right? So then use of undeclared variables, especially if it is a strongly typed language, you can't just all of a sudden say x equal 10 unless you have declared that invalid method calls. So that is you are trying to call a method which is not declared by you, or which is not a built-in method, right? So then not handling checked exceptions. So likewise, there are so many places you will get syntax errors. So those are just few examples only, right? So when it comes to programming languages, the programming languages are extremely strict on syntax errors, right? So if you have syntax error, if it is compiler-based language, definitely it is not going to compile. It is going to give you error and stop it. If it is an interpreter language, at the runtime or at the interpretation time, it is going to stop running the program, interpret and run the program. Okay. So syntax errors are detected at compile time, right? If it is a compiler-based language, or it will be detected at the interpretation or the runtime if it is a interpreted language like Python or JavaScript. Okay, but when it comes to Java, C, C++, etc., it will be detected, or the syntax errors will be detected at the compile time. Okay, and then we have another type of errors called semantic errors. So the semantic errors. So semantic means the meaning. So if you have write your code without complying to your requirement, so that means the code that you have written is not what you intended, then we say we have a semantic error, right? So usually the programmer's task is make sure that you don't write any code any create any syntax errors. At the same time, make sure you are not encountering any semantic errors, right? So if you have made any semantic errors, we call that there is a bug in your program. There's a bug in the program. So those things either the programmer has to detect, or the testers or the QA engineers has to detect, because the program, the compiler or whatever is not going to detect those kind of errors, right? So the things like, say, by mistake, rather than you add something, you subtract it, then that kind of errors are called semantic errors. Okay, right. Then we can categorize errors again, a different categorization, that is compile time errors and runtime errors. The compile time errors means the errors detected at the compilation. Okay. Then we can have runtime errors. So those are the errors detected at the runtime. So this categorization is valid only for compiler based languages like Java, C++, etc. But if it is an interpreter based language, you don't have this categorization because both the compile time and runtime is at the same time. So therefore you don't see this kind of categorization for languages like Python, JavaScript, etc. But for languages like Java, C++, we have this categorization. Some errors you detect when you are compiling, right? So all the syntax errors are compile time errors. There are some errors which occur when you are running. Those are not bugs, or those are not semantic errors. Those are also errors that occur, but those errors are detected when you are running. So those are called runtime errors. Okay. So usually runtime errors will be either detected by the developers when they run the program, or it will be detected by the end users when they use the program. Okay. So therefore runtime errors are somewhat difficult to detect unless you are fully aware of that possibility of runtime errors. Okay. So for example, there are some popular runtime errors, especially in Java, like array index out of bound error, null point error, file not found error, etc. For example, if you have created an array, say a size of 10, if you try to access the 11th element or beyond, you will not get a compile error, but when you running, you will get the error. So those kind of errors are called runtime errors. Say you are trying to access a file, that file is not there at the runtime, so then you will get the file not found runtime error, right? So those are not detected at the compile time. So those may be either some programmatic errors or some resource or connection or whatever is not available, right? So but anyway, we don't want to crash out software all of a sudden. We want to handle those kind of errors as well. Of course, the compile time errors we can always detect. The runtime errors also we have to make sure that we detect those things and handle those things. Otherwise, all of a sudden the end users will say that okay, my program crashed. So that is not a really good thing to happen, right? So that means actually your program is having some issues. Okay, right? So that is another categorization. Right. So now we are moving to the second part of our topic, that is the exception handling in Java. Okay. So exception handling is related to the what we have discussed so far, but it's a different concept as well. So we'll look into the what is mean by exception handling in Java. Okay. Right. So exception means sort of an exceptional situation. So that means a situation which is out of ordinary. So a situation which is not natural or ordinary situation. Usually when we say exception in programming, we say something bad happened or something what we have unintended has happened. So in that kind of situation also we want to handle those things very gracefully so that the program does not crash, and also we want to give a proper message to the user saying something wrong has happened. So otherwise your program is not very user friendly program. Otherwise the user is not aware of what is happening. Say assume that you are doing an online payment. All of now you enter your credit card number and everything and you submit. Now what you expect is either your transaction is success, or at least you must get a proper error message saying no, your transaction was not carried out. But if all of a sudden if you get a blank screen or something in your browser, now as an end user you are really frustrated, right? So you are really frustrated and you don't know whether it's a success or failure. So we don't want to face our users to that kind of situation. So that is why we need proper exception handling mechanism. Okay. So the possible exceptional situations might be maybe due to invalid data entering, or maybe the resource is not found like a file or database connection, or maybe connectivity with the network is not there, or maybe a security violation, or you are not supposed to access that particular resource, or you are not given access to that, or maybe you are violating some business rules. by trying doing that particular transaction. So there are sort of very broad areas where the exceptional situations can occur, right? Now let's see how to handle those things using Java language. Right. So when it comes to handling exceptional situations, there are in all the languages there was nothing called exception handling framework or exception handling mechanism. So therefore, at that time, we had to rely or we had to handle the exceptions while we are coding the business logic as well. So that means our business logic and the exception handling code was inter sort of a mix together. So that is not a very good thing to happen. So therefore, the languages like C, C++, then Java, C Sharp, they came up with the concept of exception handling mechanism. So they are our exception handling and the normal business logic is sort of a separated, right? So we have a well defined path for the exceptional flows and the normal flows, right? So that is where we have this the concept of throwing errors and catching errors, etc., or the throwing exceptions and catching exceptions. So those concepts are built into the languages like C, C++, Java, C Sharp, etc. Okay, right. So what we are going to discuss is the second approach, because the first approach is not a very good approach because it will clutter your exceptional handling with the normal business logic. Okay, right. So when it comes to Java, so they have, now we know that Java is a sort of 100% object-oriented programming language. So the exception handling is also object-oriented based. So that is why we are doing this topic after doing the object-oriented concepts, right? So we have exception or the class hierarchy for the Java exception handling. Right? We know that every class in Java is implicitly inherited from object, the class called object. Then in Java exception handling hierarchy, we have a class called throwable, right? Class called throwable. Subclass in the throwable class, we have two classes called error class and exception class. Then subclass in the exception class, we have a class called runtime exception. So when it comes to exception handling in Java, for us, the most important classes are the class called error, the class called exception, and the class called runtime exception. So those are the three classes we are really interested. But we have to understand that or remember that all three classes are derived from the class called throwable. Right, throwable. Uh, right. Now let's see. And now again, when it comes to exception handling, so there are a few things you have to remember or understand. First thing is exceptions are objects in Java. Right? All the exceptions are also objects, and also the concept of exception handling support both inheritance and polymorphism. Obviously, that is because exceptions are objects. It's going to support inheritance and polymorphism. So we are going to discuss how these concepts are related to exception handling as well. Okay, right. So it's very important that you have to remember or understand that exceptions are objects. Therefore, they are going to support the inheritance and polymorphism. Right. Of course, it's going to support all the object-oriented features, but for us, these two are really, really important. Okay. Right, as I told you, so in Java we have three type of exceptions or errors or whatever. Those are the errors, exceptions, and runtime exceptions. Okay, so let's take one by one. So let's start with what is known as exceptions. So sometimes we call them checked exceptions, right? Exceptions or checked exceptions. Then we have the runtime exceptions or unchecked exceptions. Then we have the errors. Okay, right. So the checked exceptions means, or in Java, it's an exception, means an exception which we must check or handle. It's a mandatory to handle. Right? If a method is throwing an exception, checked exception, the caller method must handle it. It's not optional. So then we call checked exception. Okay. So then we have something called runtime or unchecked exception. So the only difference between checked exception and unchecked or the runtime exception is if it is a runtime or unchecked exception, the handling or checking is optional. Right? It's optional. If we want, we can handle it. If you don't like or if you don't feel like and it's a must to handle it, we can just omit it. Right? So that is why we call it unchecked or runtime exception. Anyway, these things will be clear when we are doing some coding examples. Okay. Then the third category is errors. Right. So errors are also subclass of throwable. Usually, errors means some unrecoverable situation. So usually, if there's something wrong and we can't handle it programmatically, we say that there's error occurs. Right. For example, out of memory error, right? Stuff like that. We say because if there's a memory out, there's a shortages of memory, so you can't handle it programmatically. So it's a hardware issue. So that kind of situations, the program can raise an error, right? Raise an error. Okay. So if there's exceptional situations where the caller must handle it, we can throw a exception or checked exception. If there is exceptional situation where the caller is optional to handle it, we can raise a runtime or unchecked exception. Okay. So if it is an error that the user can't or the caller can't handle it, then we will throw in an error. If there's a exceptional situations where the user must handle it or the caller must handle it, we will throw an exception. If there is exceptional situation where the caller may or may not handle it, we will be throwing a runtime exception. Okay, so that is why we have three type of exceptions or errors. Okay. Right. So if you have any questions, you can raise those things to the WhatsApp group. Okay. Right. Right. Now let's see how this exception handling mechanism works. So the concept is basically when a program or method has encountered an exceptional situation, it can throw an exception or it can throw an exception object. Okay. So when an exceptional situation occur, it can throw an exceptional or exception. Then the caller has to either catch it, right? Either it has to catch it or it has to rethrow it. So it's very simple, right? So when there is an exceptional situation, that method has the ability to throw it, right? Throw it. Then the caller has to either catch it or the caller has to rethrow it, right? So that the other guy has to now assume that A is calling B method, A method is calling B method, and B method is calling C method. If C throws an exception, either B has to catch it or we can rethrow it so that A has to catch it. Right? A has to catch it or A has to handle it. Right? So those are the two options. So B is the one who is calling the method C. Now C has thrown an exception. Either B has to catch it and handle it, or we can pass it to the method that call the B method, so that A has to handle it. So then B will be rethrowing it. Okay, so that is how it works. So the method calls will be something like this. Exception will be coming like this, or either this will handle it or exception will be passed to the its caller. Okay, so that is how the concept of exception handling framework work in almost all the object oriented languages. Okay, right. Now let's see how to throw an exception. Right? So first thing is, if you want to throw an exception, we have to create a class, right? So we are not interested about the errors actually, because errors are sort of irrecoverable things. So therefore, we will be concentrating on either checked exceptions or runtime exceptions, because most of the time errors are built-in errors are there, which the JVM or the Java JDK has defined. Most of the time, as a programmers, we will be defining our own exceptions or our own runtime exception, right? So if you want to create our own checked exception, we will be creating a class, subclass in the exception class. If we want to create a runtime or unchecked exception, we will be creating a class, subclass in the runtime exception class. Okay, so it's very straightforward. If you want to create a checked exception by yourself, create a class, subclass in the exception class. If we want to create a class which is a runtime exception, create a class, subclass in the runtime exception class. Right. So usually we are not interested about creating subclasses of errors. Okay, right. So therefore the first task is create a class which extends from exception or runtime exception class. So if you want to make sure that your exception is a must handling one, make sure you subclass the exception class. If you want to make sure that your exception is optional to handle sort of a exception, make sure your exception is subclass from the runtime exception class. Okay, so that is the first thing. Then in your method, where that exceptional situation may occur, you have to throw it. You have to throw it when that exception occurs, or when that condition satisfies, that exceptional condition satisfies, you can throw it. Right? So first you have created your own exception class, then you can throw it. Okay, right. So then in your method body, you have to declare that you may throw that exception. Right? So those are the three things you have to do: create exception class or runtime exception class, throw it conditionally, but you are supposed to do when you are throwing the exceptions. Okay, so we will first discuss this, then we will discuss how to handle. As I told you, handling exceptions means either you have to catch it or you can rethrow it. Okay, right. Right. So this is a coding example. So we'll code this later. So I have created a exception class called my exception. So which extends from exception class. So that means basically I have created a checked exception. Checked exception. So that is why I am extending it from the exception class. If it is an unchecked exception, I will be extending from runtime exception class. Okay. So then in your method, you have to declare that you are throwing this particular exception. Now remember this, my exception is called my exception. So I am saying that this particular method may throw exception called my exception, or exception object of the type my exception. Okay, so that is your first thing, creating the exception class. Second thing or third thing, you define it in your method signature. The third thing is, of course, you can throw it. You can throw it. Okay, so when, because it's object, exception is a class, you have to create an object using the new keyword. But when you are creating objects, usually what happens is, if you have a class A, you will be creating object like this: a1 or whatever equal new a. So why you are doing that is, you need this reference so that you can use it later. Right, you can use it later. But here we are creating object and we are straight away throwing it, therefore we don't need a reference. So that is why we are just creating object and without taking a reference for that, because we don't need it, we are just going to throw it. Therefore in a single line, we are just saying throw new whatever the exception. It's something like you are writing says it. So this line is equivalent to something like this. Say my exception, say m equal new my exceptions. New my exception. Then you are throwing this m. Right, so rather than writing these two lines, what we do is, because we don't need this reference anymore, after throwing it we are not going to use it anymore, therefore we are just combining these two lines and say throw new my exception. Okay, so that is how it works. Okay, right. So that is how it works. Now let's do it as a coding example. Okay, rather than just moving through the theory. Right, so I have created a folder called my code in my code. So I'm going to take a command prompt. So I'm moving to the D drive and I'm CD into that particular folder where I'm going to write my code. Right. So now I'm going to create a class. Let's say my exception. That is my exception class. .java. So I'm following our coding conventions. So classes we use camel case with starting capital. So those are conventions, best practices. Now let's create a class. Let's say public class my exception. So as I told you, if it is check exception, you have to extend the class called exception, right? So I will be using I will be creating this as a checked exception. Therefore, I will say extends exception. So that's it. So of course, there are, if you want, you can override some methods in exception class, but for the time being, so let's just make something like this. Okay. So that is my first task. So I will be compiling that Java C my exception Java. So no message means it has been compiled. So you don't have to worry importing this class because my exception is from the Java lang package. Sorry, exception class is from the Java lang package. Therefore, you can use it without extending, without importing. So we have discussed those things under the access modifiers and packages, right? So you can find it in the YouTube as well. Right, so therefore we don't have to import the exception class because it is available without importing because it's in the Java lang package. Okay, right, now my first task is done. I created an exception class. I just name it my exception. Now let's create our class which has that risky method or the method that may throw the exception. Okay, right, so let's say my risky class. I'm just naming so that it makes a little bit sense. Right, so let's say public class risky class. Right, so let's have a method. I will make it public method. Public void. Let's say my risky method. To make it a little bit more intuitive, I will just have add a parameter because we need exceptional situation and non-exceptional or happy scenario. So therefore, I'm just going to introduce a integer parameter. I will assume that if you send me a positive value, it's a happy scenario. I will handle it properly. But if you send me a negative value, it's an exceptional situation. I can't handle it. Therefore, I'm going to throw you exception because you are sending me invalid data. Okay. So as I told you, so exceptional situations can be violation of a business rule. You are sending invalid data, or I found some issues with my site, like I don't found the resource required or whatever. So there can be so many reasons for a program to throw an exception. So in this case, I will assume that if you send me a negative value, you are sending me a wrong data. Therefore, I'm not going to do anything. I'm going to send you exception saying that exception has occurred, exceptional situation has occurred. Okay, right. So therefore, now I'm going to so the next thing is if this is a risky method, you have to say that this is a risky method. Okay, so then that so first let's have a out, sorry, system out println, and let's say let's say just hello, and we'll write the test code as well before moving to the exception handling. So let's say new test my risky class dot java. So that is going to test the class that I just created. So I try to follow all the conventions. Right, so let's make it also public class. Right, so let's have main method public static void main string args. Right, so I'm going to create an object of this particular class, my risky class. Say mr equal new my risky class. Now I'm going to call the method, right? Mr dot. So what is the method we are going to call? And that is my risky method. And it expects the integer, right? So therefore I'm just sending a dummy integer like something like 5. Right, so this is not any exceptional handling is not yet done. This is normal Java class and its test class. Okay, now let's compile all the classes and see. Now you know how to compile all the classes together. Java C star.java. Right. So no message means all the classes has been compiled. Okay, all the classes has been compiled. Now let's run it. Java, and my class is my exception. It's not going to do any fancy thing, yet it's going to say hello. Okay, so what is that error? Okay, so something, so that now, okay, now can someone tell me what kind of error is this? What kind of error is this? Now this is not a compile time error, right? So I managed to compile it without any issue, but I got an error when I'm running. So now all of a sudden the second category of error has occurred, that is as I told you, we have the compile time errors, runtime errors. So what we have encountered is a runtime error. Now you can see the theory part that we all discussed. Now we are already encountering that issue. Anyway, let's see why we are getting that error. So it seems like I haven't declared my main method properly. It says uh, define the main method as public static void blah blah blah. Now let's say whether I made a mistake here. Public static void main string args. What is that error? Static. Okay, so I have been running the other class, sorry. So that is not this class, because this class doesn't have main method, so I made a mistake. I should have been running this particular class. This is my test class, which is having the main method. Okay, right. So that is my mistake. Java. So I must write. I must run test class. Okay, test class. Now it says hello. Right. So the error was basically I was trying to run this particular class, which is not having a main method. Okay, that is my mistake. Okay, now you can see this is not a we are not doing any exception handling. We are just having class with a method. We are creating the object of that class and we are just calling the method, right? We are just calling the method. Now let's make it this sort of a method having possibility of exceptions. So that is why we created this particular exception called my exception. Now I am going to say that this method throws this particular exception. So that means it doesn't mean that always this method is going to throw this. What it says is there is a possibility of when you are calling this method, there is a possibility of this particular exception being thrown at you. So that is what this line says. Okay. Now this is a risky method. So now you have that uh, possibility of success, or you might be getting this particular exception object. Okay, so therefore now let's try to come now, because we did a change here. I'm going to compile everything again. I'm going to compile everything again. Let's see. Right, now you can see that we get a compile error. Right, compile error. So it says unsupported exception, my exception must be caught or declared to be thrown. Now remember, as I told you, when someone is calling a risky method or method that may throw you an exception, you have two options. Either you have to catch it, so that is it say must be caught, or you must rethrow it. So that is what I explained in our last slide. Okay, so either we have to catch it or we have to rethrow it. So those are the two options, right? So its compiler says now you can't just call it, right? Now earlier there was no error. I was able to call it. Now you can't call it. Now remember, so when you are doing a risky thing, usually you say that you are trying something, right? You are trying something. So therefore, what we are going to do is the first approach first. So we are not going to rethrow it. We are going to handle it, because this method may throw us exceptions. So therefore, I am going to handle it. Okay, I am going to handle it. So let's see how to handle these exception by our method. Okay, so the idea is having a try catch block. Okay, having a try catch block. Okay, so now what we are going to do is let's move on to our slides first, because now we have managed to create exception class, right, and manage to throw it, but still we are not throwing it, right? So still we are just saying that there's a possibility of throwing. Now let's throw it as well, right, to make it a little bit more meaningful. Now let's say if x is greater than 0, we'll say hello, or we will print hello in the console. That is a happy scenario. We'll say else. Else means it's less than 0, or less than, or let's say greater than or equal to 0. Less than 0 is say our exceptional scenario, that is invalid data you are sending. And now what we are going to do is, rather than writing error message here, we are going to throw you an error, because now our method signature says that there is a possibility of we throwing this exception. In the else part, actually we are going to now throw that exception. Now we are going to say throw new. So the exception is just we created is my exception, right? So now we can see, if you send me a positive value, yes, we will just print hello, but if you send me a negative value, you will be getting exception. We are going to throw you the exception. Okay, so that is the idea behind exception handling framework. Okay, right. So anyway, let's compile it again. We are going to get the same compiler anyway, because we are not handling it yet. So it says you must either catch it or redeclare it. Okay, right. Now let's see. Right. So we come back to this some points later. Right. So handling. Right. So when you handle exception, so that is the caller has to handle it. You must either catch it, or catch means you handle it. For that you have to use a try catch block. Try catch finally block, or else you can rethrow it, so that your caller have to handle it. So in that case, you have to declare that exception using a throws in your method signature as well. So we'll get back to this later. Okay. So first we are going to discuss this. Okay. Right. Now let's see. In try catch finally block, and remember try catch finally. This finally block is actually optional. Okay. Finally part is optional. If you are going to handle it, you must have the try catch, or optionally you can have the finally part as well. Right, now let's see. Let's do it as a code rather than PowerPoint. Now we are going to handle this by this particular method rather than we are rethrowing it. Right. So how to handle it is, you must have a now you can't just call it. You can just try it. Okay, you can just try it. So when you are when say in our society also, when someone, the boy or someone is trying a particular girl, we say he is trying that girl. Right. So same thing. Now you can't call it because it's a risky thing. You say let's try it. Okay, try. Then you can just try your method. Right. So whenever you have try, you must have a catch block. You must have catch block. Right. So that is how it works. Try, catch. The finally part is optional. Therefore, I am not going to use it right now. Okay, but I am going to use it only later. Okay. Now, when you are catching, you have to say which exception you are going to catch. Now, remember, it depends on the exception that this particular method throws. Now, let's see which exception this my risk method throws, or possibility of throwing. That is my exception. So, therefore, what we have to catch is my exception. It's something like a method, but it's not a method. So, but it's something like a method and parameter, right? So, therefore, so you have to use the same exception that this particular method may throw. And if this is the just like the parameter data type, then you can just give it a name, any name, just like a variable, right? So, we'll call it me. Okay, just for my exception. Okay, so then you can use whatever you want, you can do here. For example, now let's for simplicity, let's just write a message to the console, because this is just a console based application, saying exception occurred, or my exception occurred, my exception. So now there are now after this we'll say by or something, so that we can see with the what is the flow of the code run, flow of the program. Okay, so let's say by. Okay, right. So now what will happen is, now we are not calling it, we are just trying it, because this is a risky method, right? So therefore we are having it in try catch. If this method does not throw an exception after this line is executed, the control will come to here. Okay, control will come here. But if this method throw an exception after this line, control will come here. Right? Right. So that is how it happens. Okay. But in this particular case, because I am sending 5, 5 is a positive number, therefore it is not going to throw me the exception. It's just going to say hello, and it is not going to come to the else part. Therefore, it is just gracefully returning the method. So therefore, after this line, I am going to get into this particular line. But now I am not going to get any compile errors, because I am not now calling the method. I am just handling it. Try catch block, because the compile error say either you must catch it or you must rethrow it. So now I am catching it. Okay. So therefore now I must not get any compile errors unless I have made any silly mistake here. Okay. Right. So let's try to compile everything together. Right. Now I didn't get any error. So that means it's compiled. It's compiled. Now I can run it. I can run this particular class. So the output will be. So I am just calling this method. So it will go there, and it will say it will come to if condition, because it's greater than 0. It will say hello. It won't come to the else part. Then I will return from here to here, because there is no exception thrown. Therefore, it will not print this one. It will then print by. So then therefore I am going to get hello and by. Okay. Now let's see Java. Okay, now it's a hello and bye. From here it goes to the method, it's print hello, it doesn't come to the else, therefore it return. When it returns, it skips this particular thing and it goes there and it say bye. Okay, so that is the happy scenario. That is the happy scenario. Now let's try to call this with a negative number. Say something like -5. Now what will happen is, since I am sending -5, it is not going for the if condition, it is going for the else part. Right? So in the else part it says throw this particular exception. Right? So it's going to create an object of my exception, the class that I just created, create object and throw in that object to the caller. So the caller is this guy, right? So this guy is now handling it. So therefore that exception is going to be caught in this catch block. So therefore what will happen is, I am not going to get this hello message because hello message will be there only when it is the happy part. Therefore I am not going to get the hello message, but I am going to get this particular message because it will be caught in this particular catch block. Therefore it will be my exception occurred. Anyway, after that it will come to the this particular line. So therefore it will be my exception occurred and bye. Since I did a change to this particular class, I am going to recompile it because I did change this particular place. I'm going to recompile everything. Right, now I'm going to run it again. Right. Now let's see what is the output. Now it says I'm not getting the hello, I'm getting the my exception occurred. So that means it has come to this particular line. Then it says bye. So that means from here it has come to this particular line. Then it has come here. Of course, when you call this one, it goes to this particular method and go to the else part, and it's throwing the exception. It is caught here. Therefore, I got this my exception occurred output. Then it comes to this. Okay, so that is how it works. That is how it works. Now I am calling a risky method. I am handling that particular possibility of exception because the method says this possibility is there. Yes, I am handling that. Yes, I am handling that. So therefore, if I send a positive value in this particular example, I will not get any exception. But if I am sending a negative value, I am going to get the exception, which I am going to catch it, and then I will be going to the next line, and it will proceed. Right? It will proceed. Okay. So if it is not a fatal sort of situation, we can always proceed. Right? But if it is a very fatal situation, we have to stop the program as well in certain situations. Okay. But usually what will happen is we will give proper error message and we will let the user to decide what he is going to do next. Okay. Right. So now I hope you get the idea of how to handle exceptions, the basic idea. Okay. The basic idea. So if you have any questions, you can just or you can at any time you can ask also, right? Or else you can just uh, put it into the WhatsApp group, right? So I will be addressing each and every question as long as you're asking, right? So I can't scan your mind and answer your questions, right? So as long as you're asking me, I will try my best to answer all the questions and clarifications. Okay, right, right. So that is how it works. That is how it works. Now I will explain the difference between the checked exception and the unchecked or the runtime exception as well. Okay. So now remember what we created is not a what we created is a checked exception. Why? We subclass it from the exception class, right? Not from the the runtime exception class, right? So if I want to make this particular exception optional to handle, then I have to extend it from runtime runtime exception class. So that is the only difference you have to do, right? Only change you have to do. Now this exception is not a checked exception. It's still it's exception, but it's a runtime or unchecked. So when we say unchecked, it's optional to check, right? Optional to check exception. You can check it or you can just omit it. Okay, right. Now I'm going to do a small change here. Now anyway, it's going to work as it is also, right? So I can just compile everything, right? So now run time. something wrong. Runtime, I think runtime T simple, because it's a built-in class. Runtime exception. Let's see. Yes, runtime T simple. So now everything is compiled, right? So I can even run it also now. Now remember what is the value we are sending? -5. I will be getting the exception. Right? You can see my exception occurred and it says by. Right? And also if I send a positive value, I would say hello and I will get hello and by. I'm going to recompile everything and I'm going to run it again. Now you can see it's a happy scenario. Now you can see whether now it's a 100% same behavior, right? 100% same behavior. Though I just change it from checked exception to the runtime exception. Now the same behavior is there, because if you want, you can handle runtime exceptions as well, right? Because in runtime exception, only difference is if you are extending from the exception class, which become then the checked exception, you must handle it. But when it comes to runtime exception, handling is optional, right? Handling is optional. So here we handle it. We handle it. Therefore, that is fine. But handling is optional now. Now remember earlier, right? Earlier we were not able to just call it. We were not able to call it. We were forced to put a try catch block or rethrow it. But now I can just omit this because it's optional thing. Because it's optional thing. Now remember last time I got a compile error here. That is why I had to use try catch block. But now I am not going to get any compile error. Right? So now let's compile it everything. Now you can see nothing is everything is fine. But again, if I change this to exception, I am going to get the compiler saying that you are not handling this particular exception, because it's a must now. It's a checked exception. And now you can see the previous error is all there, right? Now again I am going to make it a runtime exception. Right? Now I am not handling it, but I am not going to get any error because it's an optional situation now. Right? So that's the difference between you throwing a checked exception versus your method throwing a unchecked or runtime exception. So if it is a checked exception, you must catch it, handle it, or rethrow it. But if your exception is a runtime exception, or it is extended from the runtime exception, it's purely optional. It's purely optional. Either you can handle it using a try catch block or rethrowing, or you can just call it. You can just call it. But remember, when you say it's optional, it doesn't mean that you are not getting the exception, right? For example, if you are sending -5, definitely you are going to get the exception. For example, now you can see if it is -5, it is going for the else part, and anyway we are throwing it. But still we can compile this. So that is the difference. Still we can compile this. Only thing is, now at the runtime we are going to get this exception. We are going to get this exception in the runtime. Now let's run it again. Now remember last time it was gracefully, it gave me this particular error message and say bye. But now I am not handling it. Therefore, now I am not handling it means the main method is going to handle it, or I am rethrowing it to the main method, because ultimately someone has to handle it. Then my main method is going to catch this, because I am not catching this, because it's optional to catch it. I just omit it. Because the exception that is being thrown is not a checked exception, it's a runtime exception. Now let's see what happens when you run it. Now you can see it is not gracefully terminated because I did not handle it, right? It has been handled by the JVM and says it still says it got a my exception, because the JVM got the my exception because I didn't handle it. So that is not a very good thing to do, right? But there are situations, if this method is called by another method or another method, I just pass it to the next level of the method or the caller. But in this case, I don't have to rethrow it. I can just call it, assuming that my caller is going to handle it. So that is the difference between checked exception and unchecked exception, right? If it is an unchecked exception, I can just call like this, assuming that my caller is going to handle it. But if it is a check exception, unless we are catching it, we have to, in our method also, we have to say we are also throwing it. We are also throwing it. Okay, so there is a difference between checked and unchecked exception. So I will explain it a little bit again. So let's have another method here to explain it a little bit better. Okay, right. So let's have another method called, let's say, mm, here we have the method here. Let's have it here. Public void, let's say do stuff. Let's say int x or something. Right. So now remember, this is a runtime exception. Okay, runtime exception. Now I am calling. So this particular method is going to call the MyRisky method. That is the idea. Okay. So I am sending passing this x here. Passing this x here. Right. Now because it is a runtime exception, now I am calling this particular method. I don't have to handle it. It's optional. But now you can see, because it's a runtime exception, I am not, this particular method is just calling it. Just calling it because it's optional. Assuming that if I get exception, I will be throwing it to the call of this particular method, right? So now let's make sure that rather than this method, this class is calling this particular do stuff method. Okay. Now I hope you got what I mean, right? Now here you can see that this particular test class is calling the do stuff. It is not trying or catching, because anyway do stuff is not throwing any exception. But actually what happens is it is throwing a runtime exception. Okay, and this is the guy who is going to throwing it, right? So now let's compile everything. I'm not going to get any compile errors, right? But still, if I run it, what will happen? This this method is called in this method, and it is because I am sending a minus value. I am going to get going to the else part. Now let's first do it for the happy scenario. Happy scenario. Let's compile and run it. Right. So what will happen? Do stuff method is called. That means this method, it is called in this particular method with 5, that its parameter. Now it is going for this one. It says hello. Then that it will return here. From there it will return to the test class, and then it will say bye. Okay, so it will just say hi, hello and bye. Right? Hello and bye. Hello and bye. And now let's see what will happen if you have -5. Right? -5. Now what will happen? So anyway, we are calling the do stuff method, right? Because it is not throwing any checked exception. We are not handling it. Do stuff method is also calling my risky method. Since my risky method is just throwing a runtime exception, it is also not handling it. Right? So now it is because I am sending -5, it will go to the else part. It is anyway throwing it. So this guy is also going to throw it to the its caller. Its caller is this guy, or the main method. The main method is also not handling it. Therefore, it will be handled by the JVM. Anyway, we are going to get the same exception again. Okay, that runtime error. Right, now let's compile it again because I changed it to -5. I got the error. So actually not I got the error, JVM got the error because no one is handling it. It is being thrown, but no one is handling it. Why? It's optional to handle. Therefore, now remember, it's a runtime exception. Therefore, it is optional to handle. Therefore, this guy is not handling. This guy is the one that is calling this MyRisky method, but this guy is not handling it because it's optional. And also, this main method is also not handling because it knows that it's optional. Okay. Therefore, it has been called by the JVM, which is not a very good thing to do anyway, right? Now let's change this to a normal checked exception. Right? Now it's must to handle. It's not optional, right? So now, if my exception is being thrown, you must the caller must handle it. Now you can see the my risky method is throwing this particular exception, which is now a checked exception. Therefore, now we can't just call it. We can't just call it. Either this do stuff method must handle it, or it has to rethrow it because it's a checked exception. Now definitely we are going to get compile error here because it will say you are calling a risky method which is throwing a checked exception. You are not catching it. You are not rethrowing it. Okay. Now let's see that error message. Right, now you can see it's from the myRisky class, line 12. So that is this particular line. Unsupported exception, my exception must be called or declared to be thrown. Right? So either you must have a try catch block here or you must rethrow it. Right? Anyway, we are not going to handle it here. I am going to use the second approach here because we have two options. Either we handle it, we throw it to the our caller. So let's make the second thing. If it is a runtime exception, we don't have to do that because it's implicit, because it's optional. But now either I have to need to have a try catch block here or I have to rethrow it. So because I am going to handle it here, I am going to here rethrow it. Right? I am going to say just like this guy, I am going to say I am also going to throw that. If I get this particular exception, anyway I am also going to throw it. So that is the second approach. Either you have to handle it or you have to rethrow it. Okay. But now it's a must to rethrow it because this particular method is throwing a checked exception. Okay, checked exception. Now I am throwing it, but now this guy has to now handle it because this particular method is throwing a checked exception. Now I am going to get a compile error in this particular line because now this particular issue is fixed. Though I am not having a try catch block, I am anyway rethrowing it. Now this guy is in trouble. Now this guy can't just call it. Either this guy has to rethrow it or this guy has to catch it. Okay, now I am going to get the error from here. Right, now you can see now line 5 of test my risky class, that is this particular line, it says you must either catch it, must be caught or declared to be thrown. Now because it's a checked exception, it's not a runtime or unchecked exception. Now here I am going to catch it or I have to rethrow it so that JVM has to handle it. That is not a very good thing to do. Therefore now I am going to enable this try catch block. So now this check exception which is being thrown from risky method. So this guy is not catching it. This guy is also rethrowing it, but this guy is going to catch it. This guy is going to catch it. Now remember, the first option is used by this method. The second option of rethrowing is used by the do stuff method. Okay. Now I am going to get the proper graceful termination of the program. Now I am sending -5 to the do stuff method. Do stuff method is sending that -5 to the myRisky method. MyRisky method get that -5. It is going to the else part. It is throwing that exception. That exception is coming to this particular method, and it method says I am also throwing if I get exception. Therefore, it will be coming to this particular method, and I am having a try catch block here. Therefore, it will be called here. It's going to say my exception occurs by. Okay. Now let's run it. Okay, why is that? Did I save it? I think I didn't compile it. So let's compile it again. I think I didn't compile it afterwards. Let's try to run it again. Right, so you can see my exception occurred. That is, it has come to this particular catch block, and it says bye. Okay, right. So that is, those are the two things you have to do. Either you have to catch it, or you can rethrow it, so that your caller has to catch it, or your caller can also rethrow it. But that catching or rethrowing is optional when it comes to runtime exception, or if your exception is extended from the runtime exception. But that either catching or rethrowing is a mandatory if the exception is a checked exception, right? So in this case, it is a checked exception which is being thrown here. So therefore, this guy is rethrowing it, this guy is catching it, because you have to do one of those things, right? Or it could have been handled here using try catch block. If it is handled here, this guy could have just called this particular method, without having try catch block, because it has to be handled somewhere, right? So once it is handled by your caller, you don't have to handle it again, right? You don't have to handle it again. Then you can just call that particular method. Okay. So we are covering all the possibilities. Right? For example, now if I have try catch block here, similar try catch block here, and calling it somewhere here with text. Now this guy is handling it, right? This guy is handling it. Now no point this guy handling it. Now this guy can simply call it. So it has to be handled by somewhere. Somewhere it has to be handled, not everywhere. Right? So now you can see it is handled here. Therefore, you don't have to throw any exception here. Because you are handling it. Now this guy can simply call it. Now let's compile it again. No errors. Now you can see. Now this exception has been called in this particular method itself, and it's gracefully say exception occurred. Then this guy control came back here, and it says bye. Right? So those are the possibilities. Now you can see that if there's a checked exception thrown, it must be handled somewhere, right? Or it must be rethrown until you can rethrow it to the JVM. But if it is runtime exception, handling or rethrowing is optional. But anyway, it doesn't mean that you are not getting the exception. Anyway, you will be getting the exception in case the exception is thrown. Okay, right? So then you might ask why we have two type of things, right? So called must handle and optional to handle. The reason is when you have checked exceptions, which sort of force the programmers to handle it, right? Which force the programmers to handle it. Therefore, always programmers will handle that, because otherwise the code is not going to be compiled, right? So, but it's sort of a, for the programmer it's sort of a overhead, because it has to, now this is just 2 class 3 class application. In reality, when it comes software development, real world software development, there will be thousands of classes, sometimes 10,000s of classes, right? So the method calls will be starting from one method, where it will be calling another one, maybe 20 30 method calls are there. So that is the reality. That is why we need software engineers, right? Not just the programmers to handle complexity. So in that kind of a situation, if it is checked exception, and if you are going to handle at the very end, you have to rethrow every method. You have to say rethrow. So that is, so it's sort of a overhead for the programmers. So in that case, it's architectural designer's decision. We will declare some of those exceptions as runtime exceptions, and we will give that responsibility of handling to the responsible software engineers, right? So they have to look at the documentation and handle it, though it is not enforced by the compiler, right? So it's a if you have very good disciplined software developers, we can declare a lot of exceptions as runtime exceptions, assuming that they will always catch those exceptions at one place or the other. But if you want to force that handling, we will make those exceptions check exceptions, then of course the programmer will be forced to handle it somewhere. Okay, right. So that is why we have the two type of exceptions. It's a design decisions whether we go for checked exceptions or runtime exceptions. Sometimes we go for mixture of those things. For very critical things, sometimes we go for checked exceptions, and some other stuff where the exception is going to be chained for long method call. Then sometimes we decide, okay, we'll go for runtime exceptions. Okay, right. Right. So now we have covered the bulk of the syllabus. Uh, right. Now let's see what will happen if we have multiple exceptions. Because in this case we have just one particular exception called my exception. Okay. Now let's see what will happen if our method is going to encounter different exceptional scenarios. Then we better throw different exceptions for different situations. Then the caller knows exactly what kind of a exceptional situation occur. If we are throwing the same exception for all the possible exceptional situations, the caller has no clue of what exactly went wrong. Right? So if you are saying, okay, we are throwing this particular exception, that particular exception for different scenarios, by looking at the exception object, the caller knows exactly what kind of things went wrong. Okay, so that is why usually we will be having multiple exceptions in case of that kind of situation. Okay, right. So for that we are going to create a little bit different example now. Okay, and a little bit more meaningful rather than creating just say my exceptions or whatever. Right. Let's create a few classes here. So let's create a class called account. Remember we create this particular class when we are doing the object-oriented programming also, to understand inheritance, polymorphisms, etc. So let's create a public class account. Let's say we have instance variable balance. Let's say double balance, and let's say we have a method, two methods for deposit and withdraw. Let's say public deposit. So we have to say what is the amount that we are going to deposit. Let's say double amount, and here what we are supposed to do, we are supposed to add it to the balance, right? So that means balance plus equal amount, or in other words, balance equal balance plus amount. Okay, so for the, let's create another method called deposit and withdraw, and let's make it minus equal, because when you withdraw your balance has to be deducted. Minus equal. Right now I'm done with my basic account class, but I am not handling any exceptional situations here. Now assume that there is a possibility of exception occurs. Now remember, when you go to the bank, usually if you are depositing something, usually most of the time, almost 100% of the time, they will accept your money, because bank allowed to have your money. But you will be facing some issues when you are withdrawing, right? So they are for different reasons, you will face some issues, right? For example, they may say, okay, your balance is not, your account balance is not sufficient. Okay, or if you say, okay, you are trying to withdraw too much at one particular time. Say one time from ATM machine you can only withdraw say maximum 1 lakh. So you can't take more than 1 lakh in a single say it's a ATM machine. So likewise there can be different exceptional situations. Okay, or maybe your some other credentials are wrong, or your account is blocked. Right, so there can be some exceptional situations. You go to withdraw money, but you came home without getting the money. Right, so let's try to handle those things as using exceptions. Okay, right. For that, I am going to introduce two exception classes. Let's say insufficient balance exception dot java. So that I'm going to use when your balance is not sufficient. I'm going to throw that particular class. Okay. Exception. Let's say public class. Right. So I'm going to make it checked exception extends exception class. Okay. Right. So I'm going to do another class similar. Let's say excess amount exception. That means you are trying to withdraw more than allowed for a single time. So if you are doing your final project using Java, C Sharp, definitely you must know how to handle exceptions. Otherwise, you are in trouble. Okay, you will not be able to proceed with your project. So it will be pretty much like this class. The class name is going to be different. Right. So two checked exceptions are there. Two checked exceptions are there, and also I have the account class. So let's compile this so that if there are any errors we can detect early. So I did it. Okay, so yes, that is because I did some undoing there. That is coming from the test my risk class. Okay, let's see why is that. Because I was doing some undoing. This is okay. What about this? Okay, because it is also catching, so no point catching twice. Okay, so that is why I'm getting it. So I'm going to just say throw it because it's checked exception. I have to throw it. Then that error will go away because I was doing some changes there. Right now, it's my exception is a checked exception. It is throwing it. The other guy is catching it. Now that error will go away. Now let's see whether we get errors for our new scenario. Yeah, now no errors, right? So I have the count class, I have two exception class. Now let's introduce those two exceptions together because last time we were throwing only one type of exception. Now we are going to try throw two type of exceptions for two different scenarios. Okay, so I'm first going to declare those throws. So what are the two type of exception? I'm going to say insufficient balance exception, comma. Second type of possibility is excess amount exception. Excess amount exception. So that means either this or that might be thrown. So usually only not you always you will be getting only one exception, right? So not both at the same time. So there won't be any exception thrown if it is a happy scenario. Okay. Now let's write some business logic here. Let's say if your balance is less than the amount, right? That means you try to withdraw more than your balance. We'll say we are throwing throw new. Obviously, it must be what insufficient balance exception. This is a practical scenario, right? So if you try to withdraw more than your balance, we are not going to do that. We are going to throw you an exception, or the caller is going to get this exception, right? Now again, this let's say else. Else means that that particular issue is no longer there. That means you have sufficient balance. Now we see whether though you have the balance, you let's assume that you can't withdraw more than 10,000. So let's assume like that because it's illegal. Or it's not allowed by the bank. Assume. Then now I'm going to say if amount is greater than, let's say, 20, let's say 10,000. Assume that you are not allowed to withdraw more than 10,000. Then also we are going to say, but now we are going to throw a different exception. So now we are going to say excess amount exception. You are trying to withdraw excess amount. Okay. If not, right? Sorry, not. So that is if part. This is else part. In the else part also we check something. But if it doesn't come to this particular if, that means we are okay. You are perfectly valid transaction. Then we are going to do this. Then we are going to do this. Now you can see there are two possibilities of exception being thrown, or things I have done as you expect and no exception will be thrown. Okay, right. Right, so that is how the withdraw method looks like. Now there's a possibility of either you getting insufficient balance exception or excess amount exception, or you may not get any exception, but both are checked exception. Okay, right. Now let's create a now let's compile, because if there are any errors we can detect early. Yes, there's error. Right, return type required by. Right, so I forgot to mention return as void. Those are compile errors. Right, no error. Now we are going to create a similar class, test class for account class. Let's say test account dot Java. So we need this kind of class for object-oriented programming as well. Let's say public class test account. So I'm going to create a main method. So we had a main method in our other test class. Right. So it's now going to create a count object. Let's call it A. Forget about this, and we are going to call the A dot deposit. Let's say we are going to deposit 15,000. So it's not going to be issue, because deposit method is not a risky method, right? So you can just call it. So now let's compile and run it and see. Test T must be capital because it's a public class. Class name and file name must be the same. Right. So now I can run it also. So I can just print the balance. A dot, because I made it a public. I hope I made it a public. Yeah, it's a default. So default one we can access. A dot balance. Now it must be 15,000. Okay. Now let's again compile and run it. It must be test account. Okay, I made a mistake. A must be capital. And it says balance is 15,000, obviously, because I deposited 15,000, therefore balance is 15,000. Now we can't just call this as a withdraw, because it's a risky method. Now let's try to withdraw just maybe 5,000. That is perfectly okay. But now I am going to get compile errors, because I can't call withdraw, because unlike the deposit, the withdraw is a risky method, which says it can throw this one or the other one, and both are checked exception. Therefore, I must handle it. I must handle it. So therefore, I'm going to get compile errors here. Okay, so let's compile and see. Right, now again it says withdraw method call. You have to say unsupported, unreported exception, insufficient balance exception must be caught or declared to withdrawn. So either you must catch it or rethrow. Right? So now therefore I am going to catch it because I am not. This is my final class. The main method is there. I am going to have the try catch. I am not calling. I am just trying. Then you have to have the catch block. Now there are two possibilities of exceptions. Right? So you can't just catch one exception. You have to catch both the exceptions. Right? So what are two type of exceptions? You have the insufficient balance exception. Let's call it I insufficient balance, IBE. You can give any name. And then you can say a system out printed again. Balance is not sufficient. So gracefully message. So anyway, finally we are going to print the balance. Not here. We are going to print the balance here. Okay. Right. So still we are going to get compile errors. Yes, we are catching insufficient balance exception, but we are not still catching the other excess amount exception, right? So I am going to get some compile errors. Let's compile and see. Now earlier it says insufficient balance exception is not reported or handled. Now let's see. Okay, so that is a different error because I am not having proper double quotes. So now I'm going to get the other error. And now it says excess amount exception is not handled. Right? So I have to handle that also. Now when you have multiple exceptions being thrown at you, you have two options. That is, either you can have two catch blocks or you can have single catch block with both the exceptions. Okay. So let's look at the easier option first. I'm going to have both the exceptions here. Right. So that means this exception 5 character. Right, 5 character. And then you have to say declare the other exception, that is excess amount exception. You can just call it excess amount exception or something, right? So now both the exceptions are caught. So this is the 5 character O operator. And now if it is insufficient balance exception or excess amount exception, you will get this particular you will return control will return to this particular catch block. So now I can't say exactly what is the reason. I will just say insufficient balance or excess amount, because for both the cases we are getting here insufficient balance or excess amount. So that's all I can say right now. Then we are just printing the balance. Now I am okay. Now I am not going to get any compile errors. I must be able to come because I am handling both the exceptions, and because it's there's a possibility of both one of the exception being thrown. Obviously, we are not going to get both the exception at the same times, but we are going to get we may get one of these exceptions, and we are handling both now. So I'm compiling. So that must be some other error. So there must be some syntax error. Let's see how to handle both two errors. Yeah, so that must be only once. So I made a small mistake. So your variable name must be only once, right? So those are the two possibilities. Then you have say some account error or whatever account exception. Okay. So you can't declare two variables because just this parameter can be either this type or this type. Okay, this type or this type, and this is my parameter name. Okay, right. So now I must not get that particular error. Yes, no compile errors. Now anyway, this is happy scenario. I am depositing 15,000 and withdrawing 5,000. Therefore, I am not going to get any of these exceptions. It's just going to say balance is 10,000. Okay. So therefore, let's run it and see. Test my test account. It says balance is 10,000 because it's a happy scenario, right? It didn't, it hasn't, it is not, it hasn't, the control hasn't reached any of these exception situations. Basically, it has come to this particular place and it has just returned. And I was this method uh, never reached this particular cache block because it's a happy scenario. Now let's make it an unhappy scenario. Now I have 15,000. Okay, now I have 15,000 and I try to now let's say it's not 15,000. I am depositing 5,000. I try to withdraw 7,000. So that means it's going to raise insufficient balance exception. Right? Insufficient balance exception, and of course I am catching it. Right, so therefore I am going to say, but I don't know which one is there because both are there. I will say insufficient balance or excess amount exception error message. Okay, now let's compile and see. Right, it says insufficient balance or excess amount because for both the cases I have only one cache block. Okay, again if I have something like 5,000, let's say I have 15,000 but I try to withdraw 12,000. In that case it is not the insufficient balance exception, it is excess amount because the maximum value we have set it as 10,000. Okay, now let's see whether that is also getting, but we are just going to get this particular message. Okay, so again it says because we are not sure because we have only one catch block. So that is anyway, that is one approach of handling multiple exceptions. If a method throws possibility of more than one exceptions, then if you are using a try catch block, you can have each and every exception separated by the pipe character. Then if any of these exceptions are thrown, it will reach this particular catch block. Okay, catch block. Okay, so that is the approach one. So we have second approach as well. The second approach is the more popular approach, right? So because it's more natural, that is for different exceptions having different cache blocks. Okay, so here it's a common error message. We can't tell the user exactly what is the error. Of course, there is a way of finding what is the error is by checking the type of this particular parameter, but it's more work actually. Usually we go for this particular approach when we want to give a common error message, or we don't care, or we don't want to handle those two exceptions separately. Okay, if you want to handle those two separately and do different things, we will always go for, or most of the time we go for multiple cache blocks. Okay, now I will explain the second approach. Okay, so I'm just going to cut this one. Let's call it insufficient balance exception, and then of course I can say it's insufficient balance because I'm catching only one type of exception here. But now I'm going to have another cache block. You can have any number of cache blocks, any number of cache blocks. So let's say excess amount exception. Okay, so for that now I can give a distinct error message because I'm having two cache blocks. Let's say excess amount exception. Okay, now this particular scenario is what? Excess amount exception because the balance is sufficient but we are trying to withdraw more than 10,000. Now let's compile and see whether we get that exact error message now. Let's compile everything again. Let's run it. Yes, now you can see it's a distinct error message. It says excess amount exception. Okay, excess amount exception. And also, if you try to make it, let's say you have 1000 and you try to withdraw 2000, now you are supposed to get the insufficient balance exception. Insufficient balance exception. So let's look at that one as well. Compile and run. Yes, now it says, now you can see when you have multiple catch blocks, we can specifically we can identify which particular exception has occurred. So we can either handle it properly, or we can at least give a very specific error message to the user. So that is why for different scenarios we prefer to throw different exceptions, so that the caller know exactly what kind of a issue is there. Okay, right. So now we are moving to the very final part of your exception handling topic. That is, as I told you, now you know that exceptions are sort of objects, right? It use the concept of object orientation, but still we didn't use any inheritance or something like that, right? So now remember, when it comes to exception hierarchy, exception handling, there's a class hierarchy, right? Class hierarchy. For example, everything is throwable. Either we have subclass exception or we have subclass runtime exception. Okay. So here also we can create exception hierarchy by ourselves, or here, right? So that we can use the concept like inheritance, polymorphism, etc. Now that is what we are going to do. That is our final part. Okay. Right. So now, close look at what I am going to do. Now we have two exception classes: excess amount exception and insufficient amount exception, insufficient balance exception. Now I am going to create another exception class. Let's call it account exception. Java. Account exception. Right. So now I am going to make it public class account exception. Right. So which is going to extend the exception class? Extends exception, right? Account exception. Okay, now what I'm going to do is, now these two classes earlier was extended from the exception class. Now account exception is extended from exception class. Therefore, these two classes I'm going to extend it from account exception class rather than exception class. Okay. Now that means I have class hierarchy now. That is I have a class called account exception, and extending that we have two classes, that is insufficient balance exception, and also we have uh, exceed amount exception, right? Of course the account exception is extended from the exception class, therefore all these are checked exceptions, right? All these are checked exceptions, but for these two classes now we have super class, right? So now we are going to use the polymorphism and the inheritance. Okay, especially the polymorphism. Okay, so that is why we want to create a hierarchy of these kind of classes. Okay, right. Now right. So now in our account class, sometimes we are throwing insufficient balance exception, sometimes we are throwing excess amount exception. Right. So for some scenarios it will be insufficient balance exception. For some scenarios it will be excess amount exception. And of course we are catching both now. We are catching both in multiple try catch blocks. Right. Multiple try catch blocks. Uh, So this catch and this catch. Okay. So now still this is going to work. Right. So if I compile and run it, this is going to work perfectly. So it's say insufficient balance because its balance is insufficient here. But if it is something like say 15,000, and if I try to withdraw 12,000, it's going to say excess amount exception. Let's compile it and see. Excess amount exception. So by introducing that particular superclass, I have not changed. I have not made any. Still, I have not made any change to our flow of the program. But now I have another option. That is, my insufficient balance exception is an account exception. My excess amount exception is also account exception. Therefore, when now remember we had earlier either we had to catch both the exceptions to separately, or we had the option of catching this or the other one, right? This or the other one, right? So using the pipe character or the O symbol. Now I have another option, that is, rather than catching these two separately, I can catch just one as well. Now I have another way of writing the code. Rather than saying insufficient balance exception or excess amount exception, I can say account exception. Account exception. But now, because insufficient balance exception is account exception, when I catch account exception, I will be catching insufficient balance exception. Because excess amount exception is account exception, when I catch account exception, I am catching excess amount exception as well. Right. So now again I have to say insufficient balance or excess amount. Right. So because we are just catching it only in a general way. So it's something like this, right? So now I say assume that we have a class called animal, and we have subclass called dog and cat. So when I say I am catching animal, right? So I am catching animal. Of course, I am catching dogs and cats because dog is animal, cat is animal, right? So this is something like that. So when I say I am catching account exceptions, of course I am catching whatever the subclass of account class exceptions. Okay. So now for this particular scenario, I am going to get this particular message just like having the pipe character or the other approach. Okay. Right. So let's compile and see. Excess amount exception. Why is that? Have I saved? I think I have not saved some classes. You can see this is enabled. So let's compile it again. Yes, now it's okay because I had some unsaved classes. And now I can run it. And it says insufficient balance or excess amount because we are just catching account exception, right? We're just catching account exception. So this is another way of catching exceptions. So rather than you catch specific exceptions, if you want to handle it in a common way, you can catch the superclass exception, superclass as well. Okay, superclass as well. So either if you want, you can just catch specific exceptions, or you can just catch the general exception if you are not interested in handling those separately. Okay. Right. So one final thing I am going to mention is, if you want, you can catch your superclass as well as specific as well. So that means you can have something like this as well. So that is the final thing I am going to explain. So that means I am catching account exception here. Now if you want, you can catch any specific exceptions also. So here, if it is excess amount exception, actually it should have been other way around. If you are catching a specific exception, it must come before the general exception. Okay, something like this. Right, so this is the general exception is I am catching, and now I am going to catch the specific exception. One of the specific exception, insufficient balance exception. Okay, so then I can say yes, it is insufficient balance. Now I am, so if it is not insufficient balance, it will be caught here. it will be caught here. In this case, it is not insufficient balance. In this case, it is excess amount. So therefore, it will not caught here. Therefore, it will be caught here because anyway, excess amount exception is a count exception. Of course, excess amount exception is not insufficient balance exception. Therefore, it won't come to this catch. But anyway, it's going to come to this particular catch. Right? Now let's compile and see. Insufficient balance. It must be insufficient balance exception. Right. Let's compile. Right. Now let's run. It says insufficient balance. Right. Insufficient balance. Is it insufficient balance? No, can't be. Okay, I did change the error message. So excess amount exception, I should have mentioned it as excess amount exception. Okay, so that is my error message is wrong. So let's compile it again and run. Yes, it says excess amount exception. Excess amount exception because I am specifically catching that. But if it is insufficient balance exception, it is not going to catch caught here, but it will be anyway caught here. Okay, so let's do that also. Let's say it is 5,000. I'm trying to withdraw 7,000. Now it is not excess amount. It will be insufficient. I am not catching insufficient balance exception, but anyway I am catching account exception. Therefore, it will be caught here, right? So, but I am therefore I can only give general message, okay? Because I am catching the account exception. Right, so I got the general message because I am catching only account exception. So what we'll do, why we go for this kind of situation is if there are specific exceptions we will catch, then we will catch the general exception if you want to handle those together as a general scenario. But again, one thing you have to remember is if you catch both specific and general exceptions, you must make sure that you catch your specific exceptions above the general exception. Okay, because it's otherwise what will happen is your general exception is the bigger guy, your specific exception is a smaller guy. Anyway, it will be already caught here. Therefore, this won't be run anyway. This won't be run at any time. So, therefore, if you want to catch both specific and general, first catch the specific, then catch the general. Okay, so this is okay. First catch the specific, then catch the general. But if you swap these two catch blocks, you are going to get a compiler saying that it's sort of a never it's not going to be reached that particular thing. So anyway, I will show that also. Right, so this is not going to work because I am catching the account exception above. Excess amount exception will also be already caught here. Therefore, this will be never executed. Right. So therefore, I am going to get a compiler error if you try to do this kind of a code. Right, it says oh, there's something wrong. So this catch is there. Okay, I have not terminated the try block. Okay, right. So that is a different error. That is not the real error I want. Right, it says access. Okay, so it says excess amount exception has already been caught. Right, so you can see excess amount exception is already been caught by account exception because account exception is excess amount exception is account exception. It has been already caught here, therefore it will never come here. So that is what it says. It has been already caught, so therefore you can't do that. But what you have to do is catch specific exceptions first, then catch the general exception. Okay, so that is what you are supposed to do. So this is again okay. Now we are catching specific exceptions first and then catching the general exception. Okay, right. So we are done. Right. So So one final thing I want to explain is, now remember I told you we have try catch final block, but we never use the final block. We have been using only try and catch block only, right? So the final block is there. So I'm going to use the final block here now. It says finally, so final, not final, it must be finally, finally. So that is the third part. So finally block will be called whether you you get a catch exception or you don't get a catch exception. So ideally this could have been written in the finally block as well, because anyway we are going to show them the balance. Whether you are success or you get error, we are going to show the balance. So therefore we can use the we could use the finally block to do that kind of things as well. Okay. So anyway, this is not going to change our behavior. Just I show you that it's possible to do like that, right? Uh, right. So that's it. So finary block can be used. Usually we use finary block to release database connections, etc. Because you get an error or whether you are doing it properly. Anyway, we want to release our resources. Like if you have opened a file, you want to close that file. If you are connected to the database, you want to release the database connectivity. So that kind of things can be done in the finary block. Okay. So then someone will ask, so what is the point of having finary block here? If it is somewhere here also, anyway it is going to be called, right? So why do you want to have finite blocks like this if anyway it is going to, now remember, if there is no exception it will come here and come here. If there's exception, say excess amount exception, it will from here to here, then anyway it will come here. So then someone will ask, why do you need a final block for finally block, right? So that I keep for you to think about it and do a small research, do a Google search and see, is it really need to have a finary block, right? So because and now you can see that if there's no exception from here, it will come here. If there's exception from here, it will go to the relevant exception. Anyway, it will come here. So then, why do you need to have final block? Why do you need to have final block and write it like this? If anyway it is going to come to the this particular line, that I keep it open for you to do a small research, Google search, and find out what is the real use of finally. So if you find it, you can just put your answer. Don't copy paste answer and paste it in your words. Why we have what is the real use of finally? Right, in your words, right? So that's something I like you to do a small research and find out, rather than just having it somewhere here. What is the purpose of having the finally block, right? Okay, right. So we are done now. Now let's move to our PowerPoint slide and see whether we have missed anything. Right. So we discuss about two type of errors, right? Syntax errors versus semantic errors. Anyway, we encountered some syntax errors today itself, missing semicolons and blah blah blah. The semantic errors means some meaning wise or your business logic wise you have written your logic wrongly. So that those things you have to check by doing unit testing and etc. and make sure that you write the proper logic as well. Okay, because those things will not be caught by your compiler or runtime. Okay. Then we divided it again to the compile time errors and runtime errors. The errors that we get at the compilation and the errors that we get when we are running only. Okay. So today also we encountered both the type of errors. Okay. So once you understand these things, so forget about the exams. Forget about the exams. Once you understand that there are some errors I will be catching at the compile time, there are some errors those we don't catch it in the compile time. Anyway, those things will be there in the runtime, right? So there can be some business logic errors which will never be caught by the compiler or whatever runtime, but still the result is going to be wrong. So once you have understood those things, when you are writing a program, you will try to write it proper way. So otherwise, what will happen is some people when they write a code, they take about sometimes hours and sometimes days to make it work because once they make compile errors, then there are runtime errors, then there are issues with the business logic, right? So if you are conscious about those things, you can think about all those things and one shot you can write the proper code. One shot, no compile errors. You know that I have guarded against all the runtime errors. I have not made any semantic error issues. That is what we expect from you, right? So, sort of a very perfect software developers, so that you are very productive. Otherwise, you will be spending a lot of time messing around, finding your own, fixing your own issues, fixing compile errors and all the things. You will be very unproductive and you will get frustrated. And after some time, you will see programming is not going to work for me. So actually, you are not learning properly, you are not understanding properly, and you are not doing a proper job. You are just trying to do something rather than understand and do those things properly. Okay, so that is why we have to understand those things. What are the possibilities? I know exact all the possibilities. I know how to tackle all those possibilities. Okay. Then we discuss the exception handling framework in Java. We discussed the exception hierarchy, where we didn't discuss anything about errors, but we discussed the check exception versus runtime exception. Here it is a must to handle, here it is optional to handle it. So when we say handle, either you have to catch it using try catch block or we can rethrow it. Okay, we can rethrow it. Then of course we can create an exceptional hierarchy and catch those exceptions in a polymorphic way as well. So, but anyway, you have to first catch the specific exceptions, then you have to catch the general exceptions. Then we discuss the use of finally block as well. Okay. Right. So when it comes to exceptions, of course you can have multiple try catch blocks. Say this is one method which throws particular exception. This is a different method. It's also thrown maybe a different exception. Then you can have try catch block here. You can have another try catch block here. And in between, if there are methods that you do, which are not throwing any exception, you can just call it without having try catch blocks. Right. Your method may have any number of try catch blocks for different risky methods. Okay. And also there can be nested try catch block as well. For example, now you can see this is a risky method because it has the possibility of throwing my exception. Then while you are handling the exception, you try to call another method. So that also may throw another exception. So in that case, within the catch block, you can have another try catch block, right? Say this result in exception, it will come here. Then when you are handling, you are calling another method that also result in exception, then it will come to this catch block as well, right? So likewise, you can have nested try catch blocks as well in your code. Okay, right? So then when you have multiple exceptions to handle, either you can use multiple try catch blocks or you can use a single try catch block, right? So something like this single try catch block catching both the exceptions or catching them separately, or if you have a class hierarchy, you can just catch the superclass exception, or else you can just catch the specific exception and then the superclass exception. But you can't do this kind of things where you catch the superclass first and then the specific class. No, that is not allowed, right? So this is allowed, but this is not allowed. Okay, right? So either you have to catch it or you can rethrow your exceptions, right? So we did that kind of an example, right? So then there are some built-in exceptions as well. So those are the exceptions that we have been creating, right? So in the exams, sometimes they check whether you are aware of one or two of those popular exceptions in Java JDK. Okay, so I have mentioned only two of those. So those are some popular checked exceptions, built-in exceptions. No such field exception, no such method exception. Both are checked exceptions. If a Java method is built-in method is throwing those exceptions, you have to catch, right? Then these are for some popular runtime exceptions like arithmetic exceptions, array index out of bound exceptions, string index out of bound exceptions, array store exceptions, null pointer exceptions, class cast exceptions, number format exceptions. So all those are popular runtime exceptions. That means those are optional to catch. But in case of an exception occurs, you better catch those exceptions. Okay. Right. So now let's look at some past paper questions and finish the session. Okay. Actually, not much questions are asked from your these sections because most of the questions are from object orientation and structured programming. But anyway, maybe one or two questions will be from here. Right, so let's see if the 2019 paper has any questions on exception handling. Usually just one question will be there. Right, so this is a very simple question. Select from among the following valid exception classes which is reference when a division by zero error occur. So that is actually checking your memory. I don't like these kind of questions. They are just checking your memory rather than your skills or knowledge, right? So anyway, so there are so many exceptions for different scenarios. So you better do some past papers and see whether what kind of exceptions the examiner is interested. Now it says what kind of exception is used, or what built-in exception will be thrown when you divide by zero. Or at runtime, you have a number which is divided by zero. Now you know that those who have done maths, A-level maths know that something divided by zero is infinity. So therefore we take it as a special case. So that is sort of a not the general case. Okay. Now actually you can guess it. What kind of exception you feel? Number format exception, arithmetic exception, IO exception, null pointer exception, array index out of bound exception. Now you can obviously see that array index out of bound exception is occurred when you are trying to access an array element which is out of the boundary or size. So therefore this is not going to work. So the null pointer exception occurs when your object is null, still you have not created the object, but you try to make call a method or whatever. Okay, so therefore this is not that kind of a thing. IO exceptions will occur. Anyway, we are going to discuss IO exceptions when we are doing the file handling. So you have a very small part for file handling. So IO exceptions are occurs when you try to read a file or access a file which is not there. Right? So that is definitely not this case. Right? So this is a candidate arithmetic exception. Now you can see this is arithmetic operation. Division is a arithmetic operation. So the number format exception is usually your number format is illegal, right? So that is usually when you are in the UI, you have send your number in a different format than expected, you will get that, right? So actually, I am also not memorizing these things. By looking at these answers, I feel like the B is the most probable answer. Okay. Now let's see the answer anyway. So that is checking your memory and little bit of your common sense. Okay. By looking at the name, can you guess? Now let's see what the answer is. 23. It's a B. So B means yes, arithmetic exception. Okay. and it's a, so all these are runtime exceptions. So they are not specifically mentioned whether it's a runtime exception, but these are all runtime exceptions, right? Right. So again, they are just checking your memory, right? So that is a bad thing about our examination system. Select from among the following valid exception classes which can be categorized as unchecked exceptions. Now again, they are just checking your memory. That is how examination system is all about, checking people's memory, right? Rather than their skills or whatever. Anyway, so now let's see which one is unchecked exception, right? So array index out of bound exception, it's a runtime exception. Null point exception, it's a runtime exception. IO exception, I think that is a checked exception. So I think that is a checked exception. Number format exceptions and arithmetic exceptions, I think uh, those are unchecked exceptions. Sorry. So I can't remember exactly because I am not memorizing each and every exception and remembering which one is checked, which one is unchecked. We can always refer to Java API. But I feel like null point is unchecked. Array index out of bound is definitely unchecked. It looks like arithmetic is unchecked. Number format I am not sure. I think that is also unchecked. Maybe IO exception is the only checked exception. Okay, now let's see the answer because they are just checking your memory. So you better create a list of all the unchecked exceptions and all the checked exceptions. Okay, uh, I have mentioned few of those. Now let's say 24. C. Yeah. So other than C. So IO exception is a checked exception. Anyway, you will encounter IO exception when we are doing the file handling, right? So in file handling, whenever you open a file or write a file, you have to use a try catch block. In the try catch block only you can call these methods. So because IO exception is a checked exception, right? It's not a so in that case, yeah, other than IO exception is checked exception, all the others are unchecked exception. So IO exception you must handle. Okay, you must. Anyway, you will encounter this when you are doing the file handling. So remember, all the others are runtime or unchecked exceptions. Okay. Uh, yeah. So yeah, two questions are there. Select from among the following valid options which shows the superclass of all the exceptional types. Right. So we discussed it today. So, what is the superclass of all the exceptional types? I remember we had the object class, then we had the throwable class. From the throwable class, we had the error class, then we had the exception class. From the exception class, we had the runtime exception class. So, we create subclass as runtime exception or exception. If you subclass exception, it's a check exception. If you subclass runtime exception, it's a runtime or unchecked exception. But both these and also error classes are subclass from the throwable class. So therefore the answer is either throwable to object. So object is not given because object is the implicitly super class. So in this case it must be throwable. Okay, throwable. Select from among the following valid options which can be used to manually throw an exception. So when you are manually throwing an exception, you have to say throw new. Throw new. So therefore it must be throw. Right. So another question from the exception. Select from one of the following the exception which occur when JVM runs out of memory. Now remember I mentioned that those are errors. So if JVM is running out of memory, programmatically we can't do anything. So that is called out of memory error. Right. Out of memory error. Right. So that I mentioned in the note as well. That is called out of memory error. Okay. So that is not exception. It's a it's extended from the error class. Now, if you want to, you can just double check those classes from where it is getting extended. if you do a Google search, out of memory error Java API. So there's a document called Java API which documents each and every class, built-in classes. So if you go to there, you will see that now you can see this out of memory error. So it is extended from virtual machine error, which is extended from error, which is extended from the throwable, which is extended from the object. Now you can see it's virtual out of memory error is an error, right? It's not an exception, but it is also a throwable. It is also throwable. Right? So answer is out of memory. Just they check whether you know the name. Okay. Right. So I think that's all. That's all. Right. So not much questions. Maybe 2, 3, or maybe last time I think 5 questions. Okay. Right. So if you have any questions, you can raise. Right. So I didn't get any questions in the WhatsApp. Right. None. No questions. Uh, so let's see if you have any questions in the chat because I don't see much time to see the chat. Yeah, no questions as usual. Right, so then we will stop at this point. Okay, right, thank you.